Good day, everyone. I'm Evano, and today we will talk about plastic roads. The contents of our topic for today are introduction, the main topic which is plastic roads, advantages and disadvantages, and the chemistry behind the plastic roads. So, let's start with the introduction. Plastic is the most widely used material in the present times. It, it is light in weight, moisture resistant, flexible, and very inexpensive. Plastic ubiquitous in contemporary society, stand as the most extensively employed materials due to its inherent advantages such as being lightweight, resistant to moisture, flexible, and notably economical. These commendable attributes contribute significantly to the widespread adoption of plastic across various sectors, permitting essential phases of the economy such as agriculture, automobile manufacturing, electronics, and construction. The revolutionary impact of plastic is undeniable, shaping and enhancing diverse aspects of our daily lives. However, this prevalence comes at a cost, as the very convenience and versatility that make plastic indispensable also render it a pervasive environmental issue. The plastics involved in building these roads consist mainly of common post-consumer products such as product packaging. Some of the most common plastic used in packaging are polyethylene terephthalate, polypropylene, and high and low density polyethylene. Now that we are done with the introduction, we'll move on to the main topic, which is plastic roads. So first, let's talk about Dr. Rajagopalan. He is an Indian scientist who has worked mainly in waste management. He is born in Tamil Nadu, India, and graduated at the University of Madras. And he is well known for waste management and plastic roads. So, what is plastic roads? Hindi talaga. Plastic roads are roads that are made partially or entirely from plastic or plastic composites with other materials. Plastic roads are different from standard roads in the respect the standard roads are made from asphalt concrete, which consists of a mineral aggregate and asphalt, while plastic roads are made of plastics. Plastic roads represent a distinct departure from conventional road construction methods, where the ubiquitous asphalt concrete, composed of mineral aggregates asphalt, has long reigned supreme. In a bold environmental initiative, plastic roads are crafted predomin- predominantly, if not entirely, from plastic or plastic composites blended with other materials. The key differentiator lies in the innovative use of plastic waste as the primary aggregate in lieu of traditional mineral components. This groundbreaking approach addresses two critical issues simultaneously: the burgeoning plastic waste crisis and the conventional road construction reliance on resource-intensive materials. By, by repurposing discarded plastics, this road aims to mitigate the environmental impact of plastic pollution, offering a promising avenue for plastic recycling. So, how plastic roads are created? Using plastics to make road is complicated, but it is an interesting process indeed. The first step in the procedure of making plastic road is shredding. The plastic materials received are crushed into small bits in this step. All the dust particles are also removed here. In the second step, all the crushed pieces are mixed with hot gravel. This mixture is warmed to a temperature of 160 degrees Celsius so that all the plastic melts. It is then poured onto the hot asphalt roads, and this is how the roads are paved, like here in the picture in the slide. So, after the main topic, we will talk about the advantages and disadvantages of plastic roads. For the advantages, plastic bitumen composite roads have better wear resistance than standard plastic concrete roads. Better flexibility, which results in less rotting and less need for repair. Road surfaces remain smooth, are lower maintenance, and absorb sound better. Next is using less asphalt saves on cost and resources. Asphalt concrete requires petroleum, which is becoming more sacred. The addition of plastics in asphalt can reduce the viscosity of the mix. This allows a lower working temperature, which lowers VOC and CO emissions. Next, plastics road can be built from waste plastics, the majority of which is usually put into landfill, incinerated, or polluted into the environment. Landfilling and incinerating plastics are both problematic methods of managing plastic waste. Plastic in landfills can leak pollutants into the surrounding soil. Incinerating creates gaseous pollutants such as carbon dioxide. Lastly, since plastic comes with various chemical and physical properties, roads can be re-engineered to meet specific requirements. For example, weather and wear resistance. Now for the disadvantages, pure plastic road require use of compatible plastics because, when melted, plastic of different types may face separate and cause structural weaknesses, which can lead to the premature failure. Every time maintenance is performed on these modular roads, the flow of power, water, and internet that has been installed within will be interrupted. Lastly, plastics in the road can break down into microplastics and can find their way into the soil and bodies of water. These microplastics can also absorb other pollutants. And lastly, we will talk about the chemistry behind plastic roads. The chemistry behind plastic roads involves the interaction between the plastic materials and the bituminous binder used in asphalt. Bitumen is a sticky, black, and highly viscous liquid or semi-solid form of petroleum. When waste plastic is added to the bituminous mix, it undergoes a process of melting and blending during the asphalt manufacturing process. And here are some key points regarding the chemistry of plastic roads. First is melting and blending. The plastic waste is typically shredded and mixed with the bitumen at high temperatures during the asphalt production process. The heat causes the plastic to melt and blend with the bitumen to form a homogeneous mixture. Next is enhanced properties. The addition of plastic to bituminous mixtures can enhance the properties of the road. Plastic can improve the flexibility and durability of the asphalt, making the road more resistant to cracking and deformation. This is particularly important in regions with extreme temperature variations. Next is the reduction in bitumen content. The use of plastic in road construction can also allow for a reduction in the amount of bitumen required. This is because the plastic adds some binding properties to the mixture, potentially allowing for a more efficient use of the bitumen. And lastly, environmental benefits. Incorporating waste plastic into road construction provides a potential solution for recycling plastics materials that might otherwise end up in landfills or oceans. It also reduces the demand for new bitumen, which is derived from fossil fuels. That's all for today. I hope you enjoyed watching about plastic roads, and thank you for watching, and goodbye.